Hi friends, welcome to Unit 2, Day 8. This is example 1, finding the slope of the line. So we're using the slope formula to determine the slope of each line. So we're going to do this using the slope formula it tells me to, but I'm also going to show you how you can verify it using the actual kind of geometric example that we used from above. So here, what we have is point A is at coordinate 2, 4, and point B is at coordinate 7, 5. And this is 2, 3, not 2, 4. There we go. Okay, so with this, what we're going to do now is we're going to use that slope formula. The slope formula is m equals y sub 2, sorry, you can't see it, y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. So whichever point you pick to be your first point or your second point, it doesn't matter. You'll still get the slope the same way. So for this one, I'm just going to pick point B to be my second point. So if that's my second point, then that means I'm going to have m equals, so y sub 2 in this case, your second y value, so that's 5, minus the first y value, so that's 3, all over your second x value, so that's 7, minus your your first x value, which is 2. And then now you just simplify. So always do what's in the operations in the numerator and the denominator first. So I'm going to simplify this by taking 5 minus 3, which is 2, and then 7 minus 2, which is 5. So the slope of this line is 2/5. So we rise 2, 1, 2, and then we run 5, 1, 2, 3, 4, 5. Because both of these values are positive, we have a positive slope line. If we ended up with one of these being negative, then what we would have is a negative slope line. With B, we get things a little bit different. Same idea. So here, I'm going to switch colors. So here with B, I'm going to do C being my, my first point, and then D being my second point. So C is 4, -3. D is 4, 5. Whenever you have one of your values being the same, whether it's your x value being the same or your y value being the same, that gives you kind of a special case or a special scenario. So it's good to remember these sort of problems where you have either your x or your y value being the same. So for this one, plugging in my slope formula, and I'm not going to write my slope formula each time, but you should commit it to some sort of memory so that you know, like, oh, it's going to be this value or these things. So this is going to be 5 minus -3. We'll account for the minus and negative here in a second. And then 4 minus 4. So remember, when you minus a negative, you really add. So 5 minus -3. And generally what you'll see someone do is usually put parentheses around that to show that it's minus a negative. So that's really going to be plus. So 5 plus 3 is 8. 4 minus 4 is 0. Now we can't divide by 0, so we can't simplify this down anymore. In fact, this is what we call undefined. And the slope is also undefined. And this is undefined. So because this is undefined, the slope of this particular example problem is also undefined. For C, it's very similar to B in that you have 2 points and they'll have the same, in this case, they'll have the same y value. So E is going to be 3, 4, and then F is 6. Oh, I'm using the same color that I was using for the previous problem. I said I'd switch. Let's use green. That works. So 3, 4, and then F is 6, 4. So then when I use my slope formula, m equals, so we'll call F my second point. So 4 minus, and then in this case 4 is equal to, and then I have 6 minus 3. 4 minus 4 is 0, so that simplifies to 0. And then 6 minus 3 is 3. Now a lot of students will mix B and C up. 0 divided by any number is 0, so the slope for this particular line is 0. Way of thinking about 0 is no change. There's no slope change. This is flat, it's horizontal. So the slope for this one is, in fact, 0. And then for this one here, trying to find a color I haven't used, let's use this blue here. So here I have these 2 points, G and H. So G is 6, comma 2. And then H is 2, comma 6. So here for this one, when I do my slope, H is my second point, so that'll be 6 minus 2 over, and then 2 minus 6. 6 minus 2 is 4, and 2 minus 6 is negative 4. So when I reduce this, what's going to happen is I'm going to have 4 over 4 reduces to 1, but I have a negative. A lot of students don't know where to put the negative when you have a fraction. You actually put it right in front of the fraction bar. But because this reduces to just 1 in the denominator, you could just simply leave it as negative 1, like this. And that is example 1. I'll see you in the next video. Have a good day.